Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well and your preparation for your exams and tests are going well. Here we are with another numerical on oscillation, but it is connected to the magnetic needle concept. So we can just highlight the given data as well as something we are supposed to find out. So we are supposed to find out the number of oscillations. So number of oscillation is basically your frequency. So we are asked frequency, but there is a catch over here. They are asking how many number of oscillations per minute. So whatever your answer would be, that answer would be in hertz, that is per second. But if we want to find out in per minute, we need to multiply by answer by 60, because if something is oscillating, let's say 23 times or maybe 18 times in a second, then how much it does in 60 seconds, that is in a minute. So you need to multiply 18 by 60. So this is the way how we are going to do. We will see how it works. And then they are saying that the uniform magnetic field. So the magnetic field is given, this is this, and the magnetic moment is given, moment of inertia is given, and moment of inertia is this much, and magnetic moment is given. So there are three datas: one, magnetic field; second, moment of inertia; and third, magnetic moment. So let's see how to go ahead with this. Now magnetic field is always written as B, and whatever that quantity is given, that I have written. WB stands for Weber. Weber is a unit of flux, but Weber per meter square is a unit of magnetic field, that is B. I is the moment of inertia, that is given in kg per meter square. So this is also in SI system, this is also in SI system, no need for conversion. And magnetic moment is also in ampere per meter square, this is also in SI system. So everything is given in SI system, we do not have to convert anything. They are asking number of oscillations per minute. Make sure that you know this is per minute and not per second. So we have learned about this formula, T is equal to 2 pi root of I upon mb. We have derived this formula in our regular theory class. If I want to go from time period to frequency, I'll just invert everything. So T becomes the reciprocal of time period is frequency. So the entire formula actually goes reverse. So if you see 2 becomes 1 upon 2 pi, root remains root, and I goes in the denominator and mb comes in the numerator. So the frequency is basically the inverse of time period. So the entire formula is reversed. Now from here on I'll put all the values. So 1 upon 2 pi is 3.14, root of magnetic moment is given as 3, magnetic field is given as 1.6, 10 raised to minus 5, and moment of inertia is given as 3 into 10 raised to minus 6. Now here 3 and 3 will get cancelled, and minus 6 goes up, it will become 10 raised to plus 6, and this 6 and this minus 5 will give me 10 raised to 1. Now 1.6 when I multiply by 10 raised to 1, it will give me 16, and 16 when it comes out of the root, it will become 4. So that's the reason why I have solved this entire thing. It's a very easy calculation, that's why I have written directly on 4. So 3 cancelled, this goes up, it remains 10 raised to plus 6, it will become 10 raised to 1, multiplying by 10 raised to 1 will give me 16, 16 ka root is going to give me 4. Now from here on I am seeing that 3.114 is in the denominator, and multiplying by or dividing by 3.14 would be difficult for me, so I'll just replace this by 22 by 7. So that's 22 by 7, and this 2 ones are 2 twos are, so I'll get 2 upon 22 by 7. I'll move this to 7 in the numerator, so I'll get 2 into 27 upon 22, and this is in hertz, or maybe we can call it as per second, number of oscillations per second, but then this is in per second. So if I wish to find out in a minute, I'll have to find out multiply by 60. So I'll multiply by 60, and then solving this is like 2 ones are 2 11s are and 11 ones are, and you can just cancel 5s are, and you just keep on multiplying, and you just basically solving this part. This answer would be in per minute. So the final answer comes out to be 38.18 oscillations per minute. So this is what the answer is expected as well, and we have found out the answer same. So this is what today's numerical is. So I hope you have understood the concept and the numerical. Thank you so much for watching the whole entire video. Subscribe the channel in case you have not done so yet, and keep watching the videos in a series. Thank you so much. Have a nice day. Bye.